Well, good morning or hello, or good afternoon, rather, um, depending on what class you're in. I want to go over the semester study guide that I handed out to you guys last week. If you weren't here last week, please get with Miss Taylor or Miss Smith, rather, to get this information or get this packet sheet, rather. So what I'm going to do is I'm going to I'm going to go ahead and pull that up right now so that you guys can see it. Let's see, share here. There it is. Okay, so I'm going to go ahead and share this with you right now. I'm not sure what that is. All right, and we're going to go over it. What you need to do is go ahead and get out your textbook, your core curriculum textbook, this one right here. And what I'm going to do is I'm going to go ahead and start. We're going to start with the first module of safety, and I'm going to give you a location. So I'm going to give you a few minutes to get your book out. For first period there, they're all sitting in the back there on the cabinet or shelf. So go back there, get your book, and bring it back, and let's get started here. So we're going to start with module 1, which is basic safety, construction site safety orientation. And each module is laid out with sections. So I want you to go ahead and go to section 1.1.1, and that's going to be on the first module, page 3. All right. So the question, I'm gonna give you guys just a moment to get that together. Obviously, Miss Smith, go ahead and pause this if they need a little bit more time. So we're going to go over as much as we can within 30 minutes, and then give you guys time to kind of process this stuff, and we'll go over the second half of this study sheet tomorrow. So, all right. So going over this says the 4 leading causes of death in the construction industry include electrical incidences, struck by incidents, caught in or caught between incidents. Now, you probably remember me talking about the fatal 4. Now, obviously, there's so many different other reasons and means of getting hurt or even dying in the construction field, but these are the top 4 that the industry are constantly battling. So, if you, like I said, if you go to section 1.1.1, it says incident and accident categories. Says the incidents and accidents are often categorized by the severity and the impact as follows. You have near miss, property damage, minor injuries, serious or disabling injuries, and of course fatalities. Studies have shown that for every serious or disabling injury, there are 10 injuries of a less serious nature and 30 property damage injuries or incidences. So the there are 4 leading causes of death in construction work. These are often referred to as the big 4 or fatal 4 or the focus 4. They include falls, struck by hazards, caught in between or caught between hazards, and electrical hazards. So falls is going to be the answer that we're looking for right there. All right. So let's go ahead and move to section 1.2.9. We'll flip right through here. And that is going to be on page 8. All right, 1.2.9, poor housekeeping. So it says keeping your work area clean and free of scraps or spills is referred to as, so it says in the book, housekeeping means keeping your work area clean and free of scraps, clutter, or spills. It also means being orderly and organized. Store your materials and supplies safely and label them properly, arranging your tools and equipment to permit safe, efficient work practices and easy of cleaning is also important. So in our shop, I've been having students throughout as we get all this tools and stuff in, and obviously we built the lean-to out there, so that's to accommodate all the material. The goal is that the material isn't just piled on top of each other, that it's organized so that we can go and get what we need in a orderly manner. But the key to it when it comes to our tools, we have to put them back. So hopefully, I'm hoping to get with whoever's covering for me after the Christmas holidays to possibly go out with you guys and actually build shelves, and let's try and neatly organize all these items so that they can be put away properly, so that whenever you need something, you can go get something. In the meantime, all tools need to be somewhat organized on that bench shelf below the actual bench. It's sort of like that little shelf underneath the bench there. So the so it says, going back where I was, says good housekeeping reduces the chances of slips, fires, explosions, falling objects. Here are some good housekeeping rules. So the correct answer here is going to be, it's referred to as housekeeping. We got to make sure that we keep our space clean. That's why I'm always on you guys about pick up around your work area, pick up around where you sit in the classroom. Matter of fact, literally as you know, if you guys get a couple minutes before the bell rings or whatever, just take a moment as you're getting your things together. If you see trash on the floor, pick it up. That's what makes sense to me. All right, so the next one, number 3, says HAZCOM classifies all paint, concrete, and wood dust as. So go ahead and look at section 1.3.0. It's on page 9. You don't even have to flip the page there. It's right there next to it. And it says the process of hazard recognition, evaluation, and control is the foundation of an effective safety program. When hazards are identified and as stressed, they can be addressed quickly, reducing the hazard potential. Simply put, the more aware of your surroundings and the dangers in them, the less likely you are to be involved in the incident. There is a standard rule in the United States that affects every worker in most industries. It is often referred to as HAZCOM. Now, HAZCOM is essentially know what you're working with, know, trying to get that glare out of my glasses there. But yeah, just need to get it down. There we go. Now that's a little better. All right. So you need to be aware of the material and tools that you're working with. If you're working with paint, you need to know this, you know, what are some hazards that come along with working with paint thinner, or you know, if you're working around some type of well, I mean, any type of chemical, you need to know what the chemical is. How do you deal with it? So when you're dealing with HAZCOM, you're also dealing with material safety data sheets, or what's commonly known now as safety data sheets, because it's not always materials, it's other items as well. So in those safety data sheets, essentially says, okay, this is the material, this is the compound, this is the chemical, whatever it is. If you consume it, this is what will happen. If you get in your eyes, this is what will happen. These are the steps you need to do. And most of them are going to be like call 911, go to the hospital, get medical attention. So, but HAZCOM number 3 is going to be hazardous material. Okay, they're all known as hazardous material. All right, so going to number 4. So we're going to flip a couple pages here. We're going to section 2.3.1 now. 2.3.1. So we're in the second section of this module. Let's see, 2.3.1. And you guys probably already found it. That's fine. Share that information. Looks like it's going to be on page 28 here, 29, 2.3.1. So it talks about straight ladders. So anytime we're dealing with ladders and electrical, we should rarely never ever use metal ladders around electrical equipment. So most of homeowners who are cleaning their gutters or whatever they're doing on the roofs are the ones that primarily get into this situation. And it's what they do is they'll put that metal ladder up right next to the riser. It goes up through the roof to the power company's power supply. And you put a metal contact into an electrical conductor, it's not a good situation. So we don't use metal ladders around electrical. So talking about that, number 4 says straight ladders. Metal ladders conduct electricity and should never be used around electrical equipment. So the correct answer there, which is electrical equipment. All right, so moving on to the next one. All right, we're going to section 3 now. Module 1, still in safety, section 3, 3.2.1 says the minimum distance that a spoil pile. Now, let's talk about spoil pile real quick. So if you're digging a ditch, Okay, you're digging a ditch, and this ditch is excavated or whatever, it doesn't matter. Anytime you take that dirt and you move it out of the hole and you put it right next to the ditch, that is the spoil. So that's what they're referring to. With the minimum distance that a spoil pile must be located at the edge of an excavation. What is the difference between a ditch and an excavation? An excavation is anything deeper than 5 feet. Okay, anything deeper than 5 feet is considered an excavation, and therefore the dirt that you're taking from the hole needs to be at least 2 feet away from the edge. Why is that? Well, because let's see here, 3.2.1. I still haven't got. There we go. Trenches, excavations. Trenches and excavation. Blah blah blah. That's usually not wider than 15 feet. You know, trench is dangerous, protected. Got to, because hazards involve trench and excavation work, cave-ins, water accumulation, falling objects, collapse nearby structure, etc., etc. Now, says right here, let's see. When dirt is removed from an excavation, the surrounding soil becomes unstable and the gravity can force it to collapse. So let's say you dug a trench, you put your soil out beside it, your dirt is sitting there. That dirt has weight. Okay, it weighs, and the more you put there, the more weight you're applying. Obviously, you have a ditch here. This is the top. This is going to cave this in. It's going to collapse. It's going to fill in the hole. You don't want that to happen. So many times in the construction sites, these excavations are pretty deep, and somebody will drive a vehicle too close and it would create a cave in, and unfortunately people don't make it out in time. So 2 foot, 2 feet, it must be a minimum of 2 feet away. All right, so now we're going to section 4.1.4, working near or energized electrical equipment. So number 6 right there says work that is performed at near a hazard but not in direct contact with this hazard is considered what? So it says right here, no matter what your trade, your job may include working near exposed electrical equipment or conductors. This is one example of, you guys are following me right here, right? This is an example of proximity work. Proximity means you're in the area of the work happening. If I'm in the shop and I'm cutting a board with the miter saw, you should be putting on safety glasses. You're in the proximity of the work happening. Could a piece of wood fly off and hit you? Absolutely. Because once again, you're in the proximity of hazards, potential hazards. All right, number 7. We're going to go to 5.1.2, eye and face protection. Now, some folks would say, could be safety glasses, goggles, whatever. And we ask what is, which one would be the most appropriate for which thing. If I'm welding, obviously a welding helmet. But that's not what it asks, right? Which of the following provide the best eye protection? So the best eye protection all around in construction is going to be your safety goggles. Okay, safety goggles right there. So let's see, it says wear eye protection wherever there is given a slightest chance of eye injury, and general eye protection is required at anytime you're on a job site. Face shields are added over safety glasses for certain tasks, such as grinding. Appropriate eye protection, eye or face protection is required when there is a possibility of exposure of hazards of flying particles, molten metal, liquid chemicals, acids, caustic liquids, chemical gases, and vapors, and potential injuries. Injurious light radiation. The following are examples of tasks requiring eye protection. Talks about that. And it keeps going and so forth. Regular safety glasses, I'm on page 62 now. Regular safety glasses will protect you from falling objects or from objects flying towards your face. Side shield provide additional protection and are required whenever there's a risk of flying debris. Safety goggles provide the best protection from all because they actually will seal the whole thing. If you look up there on the top page right there, just above this statement, it says you got the typical safety glasses and goggles. C is goggles. See how it seals all the way around, keeps all the dust out, and so forth. Now, I will tell you, it gets hot, they fog up. It's just something we have to work through. All right. Number 8, the type of respirator that has its own clean air supply is, and we can find that if you will go ahead and turn to 5.2.1, which happens to be, let's see, looks like it's on page 66. Different types of respirators. Now, if you'll look on page 67, it gives you an example of the 4 of the different types. You have your self-contained breathing apparatus. You have your supplied air mask, your full face mask, and your half mask. So it says the type of respirator has its own clean air supply is the SCBA. It's going to be the self-contained breathing apparatus. All right, so we're going to go ahead and move forward now. Let's go ahead and move into the math. This is the part that you guys are going to have to work a little bit. Ms. Smith, pause this video, allow the students to work it a little bit, but I'm going to work it as I go right here so that we can move this along and we can get this done. So, all right, so we're changing modules now. So now we're in module 2, which is construction math, right? Introduction to construction math. And number 1 says right here, or number 9 rather. Oh, for some reason I guess I didn't finish that one. So you have it in front of you, so we'll just walk through it together. It says a bricklayer lays 649 bricks the first day, 632 the second day, 478 the third day. During the 3-day period, the bricklayer laid how many? Go to section 1.2.0, adding and subtracting whole numbers. This is pretty basic math right here. We're going to add 632, or I'm sorry, 649, 632, and 478. We're going to add those together. Look right here just real quick. There we go. And yep, and the total is 1,759. Good job, everybody. Number 10, we have a worker. Number 10 says it's on 1.3.0, so you guys kind of see where we're at here. 1.3.0. I went too far. There it is, multiplying, dividing whole numbers. So we have a worker has been asked, I'm on page 4, has been asked to deliver 15 scaffolds to each of 26 different sites. The worker will deliver how many? A total of how many scaffolds? Well, you would multiply 15 times 26. And that comes out to 390 scaffold. Very good. All right. So which of the following fractions is equivalent fraction? Typo, equivalent. I think y'all can figure that out. Fraction for 3/8. Now, we're going to go to 2.1.0 on this, but I think we can just talk through it more than actually look through that. So we are so quick to reduce. We get, reduce, I don't know, reduce 10/16, right? Or that. But what we're not asking for that. What we're asking for is what's the equivalent to 3/8? If I multiply 3 times 8, that's going to give me 24. If I multiply 8 times 8, that's going to give me 64. So the commonality there is going to be 8. 3 times 8, 8 times 8. That's going to be your equivalent based off of the options you have right here. Okay. So we know that 3 was good to 3, but 8, you go see where I'm going with this, right? If anyone's having trouble with this, please pause this for a second, work it out on the board to illustrate to someone who may not understand it that Whatever you multiply the numerator by, you have to multiply the denominator by. Okay. All right. Moving right along. All right. So let's look at number 12. Shows part of a tape measure right there, right? So we are, number 12. We are on 4.2.1. So we jump ahead a little bit. 4.2.1. There we go. Now, and we've gone over this in class at least once or twice. We're talking about a tape measure. That little red box, the little red rectangle across the tape measure is, it says the red background for number 32 in that review or figure right there indicates what? So what does that red rectangle represent on that tape measure? So it says right here in 4.2.1 talks about the English measuring tape. There we go. It's marked similarly to the ruler described in a few additional markings along with the half-inch, quarter-inch, eighth-inch, 16th, all the things we've talked about, right? Going through with the ruler and so forth. So if you move right along a little bit as shown, see 24-inch spacing. All right, the markings in figure 15B, which is on the next page back here. It's on page 34, right there in B. What does that say? It says every 16 inches is marked with a red background. 16-inch spacing on center is used most commonly for load-bearing walls. So when we're laying out our studs, we always talk about 16 on center for our studs. So that's what that red box. It's not, it's going to be on 16, 32, 48. See where I'm going with this, right? Every 16 inches is going to be that red mark on a tape measure. The next time you go out to the shop, you see the tape measure, pull it out, take a look. You'll see it's actually there. So it's going to be, the correct answer is the marking for the studs placed on 16-inch centers in a wall structure. Very good. All right, so we're going to move on now to hand tools. And this will be the last section that we cover today. Let's see here, moving on. Hand tools. We're going to go to section 1.1.0, hammers and demolition tools. So the question here says the safest hammers are those with heads that are blank. So hammers are made in different sizes and weights for specific types of work. The safest hammers are those with heads made of alloys and drop forged steel. That is how they're made. The reason that those are the safest ones is because they're the hardest headed hammers. What you don't want is a hammer, like for example, it's like trying to drive a nail with a mallet. That would be a horrible idea. You want to make sure that you have a tool that's tempered harder than what you're striking. So you don't want a hammer that's weaker, a weaker steel that's going to dent up and mar up with every nail that you hit, because then parts of that hammer will start to fly off and potentially create injury. So number 13 says the safest hammers are those with heads that are alloy and drop forged steel. All right, the next one we're going to jump over to 1.4.2. 1.4.2. And that is at the bottom of page 11, adjustable wrenches. So it says here an adjustable wrench is a good working partner to what? Well, adjustable wrenches, commonly called crescent wrench, due to the name recognition, they are used to loosen or tighten nuts, bolts, and non-adjustable models. Although a fixed jaw wrench is usually, now an adjustable wrench is going to be, see if we have it right here. Look on figure 15, or you can see in figure 14 at the very bottom, that's an adjustable wrench. Just to make sure that we remember what those tools look like. All right. Although a fixed jaw is usually better and safer, the adjustable wrench is a good partner to non-adjustable types. For example, while a nut is being tightened with a box end wrench, the adjustable wrench might be used to hold the bolt head. Adjustable wrenches have a fixed jaw and one movable jaw. The adjusting nut on the wrench joins the teeth in the body of the wrench and moves the adjustable jaw back and forth. These wrenches typically come in lengths of, really doesn't matter. Pipe wrenches are used to tighten and loosen all types of sizes and threaded pipe. We're not talking about pipe wrenches, so they are a type of partners to pliers. They are partners to pliers. All right, number 15. Go to 1.5.0, which happens to be on page 13 right here. It says socket wrenches use a ratcheting mechanism that holds the socket and wrench in place then when pulled in one direction and releases when pulled in the opposite direction. So what type of mechanism do socket wrenches use? They use a ratcheting motion. Okay. If you don't know what those look like, look at figure 16 at the bottom of the page 13. All right. So let's look at 1.5.2. 1.5.2, torque wrenches. Okay, so torque wrenches are used to determine how much torque is required to loosen a rusted bolt. Wrong. Torque wrenches are designed to determine how tight to tighten that bolt. It has nothing to do with loosening a bolt. So, torque wrench actually looks just like, gives you example of different ones. And like I said, they're used to determine how tight something is. Yeah. All right. Number 17, 1.6.0 happens to be on page 15 right here. Pliers should not be used on a nut or bolt because they might. Okay. Now we know what pliers look like, right? Pliers are going to be these on the next page here in figure 19. Pliers have purpose. Pliers are used for all sorts of amazing things. However, we got to be careful with them because they will strip off the tip of the bolt. If I have a bolt and I'm like, I got pliers, wrenches are over there, stop, go get the wrench. The reason being is if you don't have, if they strip or if they slip any at all, it's going to round the head of that nut off. When that nut's rounded off, you cannot put a wrench back on it. You're stuck using pliers for the remainder of its existence. It is what it is. So it says here, pliers are not generally considered wrenches. They are hinged tools. The jaws are adjustable because the handles move around a hinged point. Pliers are generally used to hold, cut, and bend wire and soft metals. Pliers should not be used to tighten or loosen hardware such as bolts or nuts because they will round off the edges of the hex head. Okay. Let's see, number 18, 1.6.3. We are flipping over here to page 16. Straight out the gate. Lyman pliers, also known as side cutters, have wider, heavier jaws than slip joint pliers. They are typically used to cut heavy or large gauged wire and hold work. What was the question? What type of pliers could be used for cutting heavy duty wire? Lyman pliers. The example of that is C on figure 19 right there. It's what we use in the electrical career field. All right, number 19. Number 19, 2.4.1, 2.1.4, I'm sorry, 2.1.4, we're talking about laser measuring tools. Talk about those real quick. There are certain situations to where I used to own one myself. I'm sure they've evolved a lot since I've owned them way back when. There's going to be times where you're going to run that tape measure out and it's going to fall. Run the tape measure out and it's going to fall. You don't have someone that help you. You need to get a measurement of that space, that distance, that length, that whatever. So you would use a laser measuring tool. And the benefit to it is you can measure further distances. Because what I would do is get in a big garage. There's only so far you can reach, and then you're like, so if you can't measure the floor and make that, your template, whatever, and you have to work it from the ceiling, a laser works perfect. But it's a laser. It works off of a sonic, like a bat. It has that sonar that bounces back to it. So it has to hit a flat surface so that sonar can come back to tell it how long it took it to get from point A to point B, or point B back to A. In that case, it's, because it has to come back to the instrument. So it has to be laying flat. It has to shoot and actually hit into the wall so that the sonar can come back to give it that information. It's pretty accurate. But like I said, it's one of those tools that you use and you rarely used it. So I think the battery ended up corroding in it because it just didn't get, just didn't use it as often as I would most tools. But the answer is, the advantage of a laser measuring tool is that it can take longer measurements. It can take longer measurements here. All right. So the last one we're going to talk about today is number 20, 2.2.0, which is right here on page 21. A level is a tool used to determine how level a horizontal surface or plumb a vertical surface. So in order to determine whether a surface is level, you would check the horizontal surface. Remember this. This is horizontal, side to side. This is plumb, which is vertical. Horizontal, vertical. Okay? Maybe more like that. Perfectly level vertical is known as plumb. Okay? So, in order to determine whether a surface is level, check the horizontal surface. Okay, I want you to take this information, and I hope you guys were writing down these answers. I hope you were writing down these answers. If not, I hope you got a really good friend that did write down the answers. These questions will be on the test. It's going to be multiple choice. It's probably not even going to be all 30, 40, whatever, however many there are on here. So the test isn't going to be crazy hard, but if you don't look at this information or you don't understand this information, you're not going to do well on this test. So I strongly encourage you to take advantage of this review, and so that you can get the study the right information. So anyway, this is all I'm going to have for you guys today. Tomorrow we'll pick up on number 21 and finish this thing out. So hope you guys have a great day.